Bismillahirrahmanirrahim. Day 9. Glycolysis. Breaking down of glucose for producing energy. Welcome to day 9. Today we explore glycolysis, the first and the most fundamental pathway of glucose metabolism in our body. It is how your cell begin turning sugar into a usable energy. Number 1. What is glycolysis? Glycolysis is a 10-step biochemical pathway occur in the cytoplasm of all cells. It breaks down one glucose molecule, which is formed of 6 carbon, into 2 molecules of pyruvate. Okay, these 2 molecules of pyruvate, each one of them is 3 carbon each. This process produces energy in the form of 2 ATP and 2 NADH. Okay, 2 ATP are a net gain. What I meant by net gain? Because when we enter in the detail of the pathway, we investigate in the first step 2 ATP, we harvest in the last steps 4 ATP, so the net gain is 2 ATP. Also produced 2 NADH. These NADH will be introduced to the electron transport chain, oxidized, and produce ATP. The glycolysis is divided into 2 phases. The number 1 is energy investment phase. It is from step 1 to 5. We use 2 ATP, we invest 2 ATP to activate the glucose. Okay, so we use it to prepare glucose for splitting. Okay, this is what I mean by activation. Okay, the other steps, from 6 to 10, from 6 to 10 step, there will be the energy B of phase. We gain 4 ATP and 2 NADH are produced. So the net gate, we investigate 2 ATP, investigate 2 ATP and have 4, so the net is a 2 ATP, 2 NADH and 2 pyruvate. Why is glycolysis important? Number 1, it is universal. It occurs in all organisms, okay, even without oxygen. So it can work aerobically and anaerobically. Okay, anaerobic energy critical during intense muscle activity. When we need anaerobic energy, number 1 in organelle, in cell like RBCs, which contain no mitochondria. Okay, we have to work anaerobically in the muscle during the intense muscle activity, when the aerobic glycolysis and aerobic metabolism reach its maximum and I still need more energy, so I use anaerobic energy. It also provides intermediate for other metabolic pathway like tricarboxylic acid cycle and fermentation and amino acid synthesis. Glycolysis can be produced pyruvic acid. Pyruvic acid will form acetyl coenzyme that will be complete its oxidations in Krebs cycle. Pyruvic acid can be used to synthesize an amino acid. Okay, dihydroxyacetone phosphate that produced during glycolysis can be used to form triacylglycerol. So it provides intermediate used in other metabolic pathway. Fate of pyruvate. This pyruvate, what will happen for it? After glycolysis, pyruvate can follow different pathway. It may be continue aerobic or anaerobic. aerobic conditions, which mean we having oxygen, okay? This pyruvate will enter the mitochondria, converted to through pyruvate dehydrogenase into acetyl coenzyme that will enter Krebs cycle and oxidize it and form NADH and FADH that will be entered to the electron transport chain and produce ATP. Okay. In states of no oxygen, like in RBCs and intense muscle exercise, anaerobic, this pyruvic will be converted to lactate in human or ethanol in yeast. In summary, glycolysis is the starting point of energy extraction from glucose. Join us tomorrow in D10, the citric acid cycle, energy production from pyruvate. Thank you.